Okay, let's take a look at how we can use the model in real time. So the first thing I need to do is run hachi run and then the train model. And what this is going to do is expose the model via OSC such that it can receive and send data. So in Max, the way that I can send OSC data to Hachimachi is using the UDP send object. And here I can see that I need to pass the host and the port. So this would be the address, so 127.0.0.1, and the input port is going to be 8000. So if I say 127.0.0.1 and then 8000, I can send data to the model. To receive data from the model, I can use the UDP receive, and I can see that the output port is going to be the port 9000. So let's open the console, and I'm going to connect this over here, actually, because it's easier to visualize. And let's see, or let's check that the model is actually receiving the data. So I'm going to send the sample route, which is going to trigger the model to output anything as that is part of the learned distribution from the data that we fed it. So I can see that when I send the message, I get this output back. Every time it's going to be different. And so the first thing that I want to do is just get rid of the output route. So I can say route output, and this is going to give me the data by itself. And I can see that I'm getting 4 values. So if I look at the training data, I can see that I have pitch, velocity, duration, and channel. And this is what we have here. So I have a MIDI pitch, MIDI velocity, duration in seconds, and then the MIDI channel. So what I want to do first is convert this data into a MIDI note that I can listen to. So I'm going to use a trigger because I'm going to be using this list or the data to fed it back into the model. But let's do unpack FFFI for float and I for integer. And this is going to be passed to make note. Now, if you notice, make note allows me to use pitch, velocity, and duration. But if I want to also pass the MIDI channel, I need to provide default values for the channel. So I need to say something like 60, 1000, and then 1. And this is going to create a fourth inlet that allows me to connect it here. Now, as I mentioned, the output from Hachimachi for the duration is going to be in seconds. So if I want this to be a milliseconds, I just need to multiply it by 1000. And then all I need to do is pass this to note out. Now, before I play it, I want to set the port to from max 1, which is going to allow me to hear the playback or route the playback to the MIDI notes to Ableton, so that I can have a better quality output. So let's hear. Okay, so it's working. Now here's the way Hachimachi works. To generate data, we need to provide Hachimachi with the current event, and what Hachimachi is going to do is predict the next event. What we're going to do now is going to be the very basics of real-time generation, whereby we let the model generate data on its own. We're going to next take a look at how we can interact with the model, but for now we're going to just let the model generate data by itself. And the way we do that is the output data, we're going to feed it back into the model. And the way we do that is by sending the data through the input route. And so all I need to do is connect this back. So once I send this message, it's going to trigger an output, and the output is going to be fed back into the model so that it generates the next one and just going to run on a loop. This is known as an auto-regressive loop. So once I send this message, we're going to hear the model generate data endlessly until I stop it. So here we go. disconnect this so that it stops. Obviously, this is not the way that we typically want to be the model to behave. We want the model to sort of take into account things that we do. So that is going to be the subject of the next video.